All right, today we're going to talk about finding volumes of solids of revolution using cylindrical shells, but we're going to talk about using cylindrical shells when the axis of revolution, or rotation, is horizontal. So if you think about what we've done before, okay, so before, let's say, we had this as a graph, and if we wanted to rotate it about a vertical axis, we thought about shells that stood upright, okay? And that's great. We think about shells that look like this. But that's with a vertical axis of rotation. We're flipping things around here. Now, if we're flipping things around a horizontal axis of rotation, then let's say it's this axis right here. Well, then we have to think about shells that are like this, oriented about the x-axis. So I'm just trying to draw them. See how they're kind of they're on the side? Yeah. So they kind of look like this, you see? And again, we can find the volume of the solid of revolution because it's the width of the edges here, the sides of the cylinders. Those all sweep through three-dimensional space and they form your solid, okay? So it's when the cylinders are sideways, that's what we're focusing on today, sideways cylinders. All right, so over here, for 33A, we're going to rotate about the x-axis, okay? It's our axis of rotation. So we are trying to find, this solid that's rotated this way, right? Okay? Oh, that looks more like the discs, sorry. But anyways, they're going to be like this, right? Okay, those are the shells, you see? And we're going to stack them all up, put like an infinite number of them, use an integral, and we're going to stack them all up and we're going to get this three-dimensional. All right, so as before, and again, I kind of have to go back to the way we did this before. With the upright shells, okay, here's a couple shells that are in the upright position, right? With those upright shells, the volume was based on the volume of the edge of the cylinder, which is 2 pi RH, okay? And we did, careful now, we did this, 2 pi, we did an integral, and the r was x, the little width of the sidewalls were dx, right? The height of the cylinders were all y equals something something x something, so that was some equation, function in terms of x. And our limits of integration were also x, the same as all the x in the x. So here we go from 0 to whatever this is, right? So these were all x's as well, x1, x2. So when we have the cylinders upright, they're all x, it's all x stuff. Well now, with the cylinders the other way around, okay, it's going to be all y. All right, so we're still going to have 2 pi, okay, because it's 2 pi RH, but instead of dx, it's going to be dy. All right, yeah. Instead of the radius is not x anymore, but the radius would be, here, look at this, it's in the y direction, so the radius is y. And the function here, if we're talking about heights, this can vary as y increases or as y changes, the height of the function that would be in terms of y would change. So this is going to be some height, which is going to be the function where its x is isolated, all right? And of course, this is going to be a y value and a y value. So that's really important when we flip the cylinders on the side, that all of this stuff changes to y, okay? Everything's exact same, except things are in terms of y now. And we picture these cylinders sideways, like this. Here's our axis of rotation. Let me draw that just a bit better. Okay, there's one such cylinder. Okay, dy, the thickness of the sidewall. The radius in the y direction. The height is the function in terms of y. Okay, so for 33A, let's take a look at 33A here. I'm just going to bring this up towards the top here so we can kind of keep that in mind. But what do we do here? Well, v equals 2 pi. I'm going to leave the limits of integration alone for a second. Because the radius, okay, the axis of symmetry is just y equals 0. And so whatever y is, that is exactly what the radius of the shells are going to be, okay? So when the axis of symmetry is right on the x-axis here, where y equals 0, your radius is always just y. And we're going to talk about these other ones here before the lesson is done. But for this case, when the axis of rotation is right on y equals 0, it's just y. Okay? Okay, so, and the other one, okay, so the other thing is the height, right, is this in terms of y. So it's just going to be 12 times y squared minus y cubed dy. Now, the limits of integration, we're going to take all of the cylinders, okay, starting at y equals what? Well, starting at y equals 0, and we're going to let y change until y gets to 1. So the limits of integration are going to be from 0 here to 1. So that's the stacks of cylinders are going to be stacked starting at 0 here, and then they're going to be stacked all the way until we get to y equals 1. Then we stop stacking. Okay, so that's the limits of integration. All right, 0 to 1. Okay, so we got this far here now. Just a little note here, okay? If you're doing this by hand, this is y times 12 times y squared minus y cubed. This 12 is just a constant. I would maybe think about bringing that out so we just have v equals 24 pi. And then you can just have y times y squared minus y cubed here. You see that? Now it becomes a little bit easier. And I'll just show you what happens from here on. You want to multiply that in. Why don't you give that a try, actually? Why don't you give that a try to do this by hand, and I'll show you, walk you through my solution in a moment. So just give that a try here now to finish finding volume here. All right, I hope you had a chance to try that out here. By hand, again, you take the integral here, and what you do is we just add 1 to the exponent. So that's going to be a 4, and then you divide by 4. That's 1/4 y to the 4th is the integral, or the antiderivative of this term, minus the antiderivative of this term is 1/5 y to the 5th. You evaluate that from 0 to 1. And so we get 1/4 minus 1/5 minus 0 minus 0. And you simplify that. You should get 6 pi over 5. And if you put units cubed, that's fine. You don't have to. All right, so that would be the answer to A there. Okay. Now we're gonna do another one where we have an axis of rotation that's not 0, and this is where it gets a little bit tricky. So the tricky part of this lesson, I think, is dealing with these axis of symmetries. Okay, so we're now going to look at what happens when we have right here. Okay, this is going to be C. The axis of symmetry is y equals 1, right there. Okay. Now the radius is what's the problem here. Okay, and I think the best way to explain this, because if you remember, we usually do, y minus the axis of symmetry, but we don't always do that. It depends where the axis of symmetry is, and it depends where all the y values are. So, for example, before we had an axis of symmetry axis of rotation down here, and we just did y equals, is our radius. Well, if you think about the y values are here, these are the y values that range all the way from here to here, right? So what we want is we want a radius that's positive. So if the axis of symmetry is below where the y values are, we go y minus the axis of symmetry. So in our first example, this would have been y minus 0. That's what we used. Well, with this example, you want the radius to be positive. So we're going to take the radius, or the axis of rotation, because that's larger than the y values. We're going to go axis of rotation minus y. Okay, so in this case, we're going to do a large value minus small because we want the radius to be positive. So I'm going to go y equals 1 minus y, or 1 minus y for the radius. Okay, all right. Now again, for C, let me just run over this right now. For C, right, the line is way up here. Which one's bigger? The line. So radius will be 8/5 minus y. Down here, negative 2/5, down there, y is larger. So for the radius, we use y minus negative 2/5, or y plus 2/5. Okay? So we want the radius always to be positive. So that when the axis of rotation for the solid is either above or below the solid, that's a good rule to follow. If it's right in the middle, okay, we'll talk about that another time. But if it's above or below, take the large minus the small. So here's the radius for, what are we doing? We're doing B. Okay. So again, volume equals 2 pi times some integral. The radius, well, we just said was going to be 1 minus y. 1 minus y. And that's going to be the radius. And we are going to go from 0 to 1. That's where the y values are. That's where the shells are going to be, right? We start at 0 and we end at 1. That's good. So that's going to be 0 to 1 like before. And then, of course, the height of each shell, it just matches the function in terms of y. So 12 times y squared minus y cubed, dy. I would bring that 12 out again. You don't have to, but you can to make this 24 pi and get rid of that 12 in there. And now we're going to multiply these out. So I'll just maybe do this real quick with you. Whoops. Oh, no, that's bad. Where was I? Here? Yes. Okay, good. So volume, 24 pi times the integral from 0 to 1 of, let's do a FOIL method here, right? So it's going to be y squared minus y cubed minus y to cubed, we can do these two, and then minus plus, y to the fourth dy. So I can now take the integral. I should simplify it, I guess. 24 pi, 0 to 1. Let's do y to the fourth written first, and then minus 2y cubed. See that? There's two of them. Plus y squared dy. And when we get to that point, you should be able to do that again by hand, evaluate from 1 down to 0. And you should get a volume there for B of, that's why, 4/5 pi, or 4 pi over 5. Okay? And if you want to do this on your calculator too, I mean, you can do this try this on your calculator. You can do it by hand. You should practice doing this by hand. But you type into your calculator, find the integral using your calculator. That might work too. Okay, so again, this isn't an instruction on finding integrals, but more so just understanding how these cylindrical shells on the side with the horizontal axis works. So I'm going to do C as well here for you. Here's C. And, what? C? Wasn't that just C? Oh, no, that was B. Okay, I tell you what, let's not do C, let's do D. Let's do D. Because, yeah, here we go, boom, D. The axis is not up here. Let's do the axis way down here, okay? So again, 2 pi RH, that's our model, right? Our cylinders are definitely, they're definitely sideways. Now, the first cylinder, if we're rotating around here, the first cylinder is going to have pretty huge radius, isn't it? Right? And pretty much a height of 0, right? This one is going to have another huge radius, like huge, humongo, and a height of this. So our radius is going to be whatever y is plus this distance. You see? Whatever y is plus this distance. Or, as I mentioned before, the y is larger, the -2/5 is smaller, so y minus -2/5. So r is y minus -2/5, or y plus 2/5. That's going to be your r. And I think that's the trickiest, okay? If you had this graph, if this was somehow in terms of y, if y equals, you'd have to isolate for x. But luckily it's given to us here. So volume is 2 pi RH. Well, 2 pi, now the RH is going to have to come from an integral, because we're piling up cylindrical shells, and we're finding out what all of the widths of the outside layer of all those shells, what they add up to be, right? That's going to be our volume of our solid revolution. So we are going to go from 0 to 1 here still, right? All the y values range from 0 to 1. That's great. This is a dy. Awesome. Our radius, we said, was y plus 2/5. Great. And our height is still just this equation. And if you're having trouble with that, okay, just think about this. As y changes, the height is going to change with it. So don't worry about this, oh my goodness, we have two of the same heights here, it's not a function. Well, it is a function when you solve for x. That actually is a function. Because as y changes, the height, if you want to call it the height of this, changes as well. So y comes here, what's the height? Well, it's here. It's governed by this, this graph, see? So you're always going to get, as y changes, you're always going to get these circled values here as the values for your heights. And that's no problem at all. It would be the same as if, I don't want to confuse you, but it would be the same as if you were doing this. X grows, no problem. Y is just these values, right? It's just these values up here, including, comes back down. No big deal. So it's just the same thing except tilted. All right, so all that to say, we still got 12, y squared minus y cubed. And I'd take that 12 out of there, make it a 24 over here, and so on. So this is going to be a little bit tricky. You got a FOIL here. Okay, let me see if I can simplify this a little bit for you. So 24 pi, and what is this, d? Okay, so this is going to be okay, let me just do one step at a time for you. So this is going to be, when it's all said and done, it's negative y to the 4th plus 3/5 y cubed plus 2/5 y squared dy. Whoa, dy. Ah, that's a typo there. dy on my page. dy. All right. Now, taking the integrals of each of these, no big deal at all. So you have 24 pi. This is going to be, well, I can do it for you. Negative 1/5 y to the 5th. This is going to go up to a 4, and so I have to do multiply by 1 over 4. So 3 over 20. 3 over 4 times 5. 3 over 20 y to the 4th. And then this is going to be this 2 is going to go up to a 3, so 5 times 3 is 15, so plus 2 over 15 y cubed. Okay, where am I? Just make sure I'm not lying to you. And then this is going to be evaluated from 0 to 1. Let me just double check that. Beauty. Okay, so that might look really gross to you, I'm not sure, but plug 1 in first. So 24 pi, and then plug 1 into here first to y, wherever you see y, and then subtract whatever 0 is in for y. So this is going to be 0 plus 0 plus 0. All right. So the volume, again, this is not the lesson on how to do this, but the volume here should end up to be just 2 pi. It should end up to be just 2 pi for an answer for D, right? Okay, 2 pi. Okay, so I hope that makes sense. I will show you some answers to the rest of 33 and even 34, because I'm going to get you to do 34 as well, right here. And what's the height here of these cylinder shells, okay, it's not just one equation involved, it's actually 2 equations. So you got to find the difference of these equations, this being the top equation, the maximum equation, this being the minimum, right? So you got to do this one, subtract this one to find the height of the cylinders now. Okay, and depending on the axis of rotation, you know what to do. The largest value minus the smaller value. So for 33 and 34, I'll get you to work on 33 and 34 that are shown right here. And I'll show you the solutions to those. So here again, here's 33 and 34. And here are your solutions. Somewhere, right here. Okay. So there's 33A and B and 34A and B. Uh, 33 C and D and 34 C and D. All right, happy trails on that one.